Hi, and welcome to Meet a Google Researcher, a series where we get to meet some folks who are advancing the state of the art in helpful technology, tackling some incredibly difficult problems. I'm Drew Calcagno, and I'll be your host. Today I have the pleasure of speaking with some researchers who are changing the game in text-to-image models. These are the types of artificial intelligence that can generate pictures based on whatever you type in. Something like a goose drinking a cappuccino painted in the style of Van Gogh. But it's not all frivolous creation. In a recent blog post discussing these types of models, Fredo Durand, who's a prominent MIT professor, wrote that AI image synthesis is the biggest innovation in image making in the visual arts since the invention of photography. Here at Google Research, we have two different approaches to this amazing capability, and they're called Imagen and Parti. With these, Google Research's scientists have generated novel ways to have a mind-to-visual connection through language. And this family of models has the potential to make the creative process more accessible for everyday people, as well as making a major new tool in an artist's toolbox. This is manifestation in software, speaking things into existence. Today I'm going to talk with Mohammad Norouzi and Jason Baldridge, two leading research scientists who have helped make these models and are pioneering the field. Welcome, Mohammad and Jason. I'm so glad that you're here. Mohammad, can you introduce yourself?
Yeah, thanks for having us. My name is Mohammad. I've been a researcher at Google Research for 6.5 years now. I did my PhD in computer science and then basically joined Google right away. I was in Mountain View for a couple years and moved back to Toronto. And like I said, I'm on the Brain team, which was led by Jeff Hinton and now by David Fleet.
Awesome.
Passing to Jason.
Well, it took a little bit longer for me to find my way to Google. I did a PhD and postdoc at the University of Edinburgh in Scotland, and then joined UT Austin as a faculty member in the linguistics department. Almost joined Google at that time in 2005,
Nice.
But it took me another 12 years to actually get to join Google. And then, now I've been here for 5 years and loving it, working in Google Austin.
Excellent. And so how did you get into this text-to-image field, and how did the field come to be what it is today?
Yeah, so there's quite a long history going back to the 1980s even, and with some significant work with a system called WordZai around 2000, where basically they were using computer graphics to generate images within a constrained vocabulary using sort of more symbolic methods. But with the rise of deep learning, there was quite a new set of capabilities that came from learning through data and being able to generate a much wider range of images. And so our team started working on that in part because we were focused on vision and language navigation and grounded language understanding specifically. And so part of the idea there is that if I want to have an agent that is going to kind of intelligently find its way around a room or perform actions and so on, it should be able to visualize futures conditioned on the instructions or the things that are being said around it. So for example, if I want to tell you to go to the refrigerator and get a bottle of water or something like that, I might tell you, hey, go out of the room, turn left, go by the table, and then you'll find the refrigerator there. And you might build a mental imagery of that.
Right.
And so part of what we wanted to do was find ways to convert words into mental imagery that we could then use for our agents to do simulations of their futures and that. That got us working on text image generation because that was a pretty, like a more constrained problem, let's say. And then it turns out that a lot of innovations have been happening and we've been contributing to that. And it's just a really exciting space.
I feel like it's an incredibly exciting space. And so you have two different approaches to this challenge. And so can you tell me about Imagen and Parti, and which one were you working on, Mohammad?
Right, so there's really a transformation in the making, and we are humbled to be part of it. There are other models outside Google, DALL-E from OpenAI. There's a company called Midjourney. There's Stable Diffusion, DALL-E Mini. Lots of excitement in the community, and at Google Research, we developed Imagen and Parti. It's really finally a moment that we can turn a high-level description of a scene as a sequence of words into a high-fidelity image that can capture various styles and various modalities. Now, in particular, Imagen is a diffusion model.
Okay.
Meaning
what's that?
So it's actually an intuitive way of generating images, in that you generate noisy versions of the image and iteratively refine it in parallel across all of the pixels. So more specifically, you start from pure noise and then try to connect the dots in the noise patterns and see things and try to kind of denoise and iteratively have a dog pop up or a scene pop up. And so it happens through a process of refinement. We often have hundreds of steps to finally get to an image.
You said it was intuitive. That sounds incredibly complex.
So intuitive in the sense that if you're an artist and if you're making a painting, you often don't start by laying out the details of pixels in the top left corner of an image. You start with kind of high level description of, maybe you start sketching and then iterate and look at your canvas and improve, etc. That's what I meant. Why don't I pass to Jason to tell us about Parti?
Yeah, and I would almost say that Parti builds on what is a very non-intuitive way of generating images from text. And this was originally pioneered by the DALI and Calcagno models. And essentially what they did is say, let's treat this problem of converting text into images as a form of machine translation problem. And the way that they do that is they say, well, let's take an image and kind of cut it up into a grid of patches, and then turn this two-dimensional object into a one-dimensional sequence. And then we do essentially machine translation from the textual inputs into these image outputs. And Mohammad actually worked on Google's neural machine translation project a while ago. So we're basically building on stuff that Mohammad and Yonghui and others did many years ago with essentially these autoregressive models for machine translation. But now the foreign language is images. We just need to have a final layer as well that can take this sort of set of image tokens that we produced out of the translation into a final image.
And so it seems like you were using different fields before this. So you're talking about translation and these different approaches, diffusion, autoregressive. What got you specifically, Jason, into this field? Were you working on translation before, or what was your progress into it?
Well, part of it was actually, my team and I had been working on a previous model called XMC GAN, which was a generative adversarial network approach. And this was from early last year, and the results that we had at that time, I would say, hadn't quite arrived. They were making progress. We were starting to produce images that you could see, like, there are people in here, there's a cake here, and things like that, but it didn't look just right. With the advent of the first DALI and Calcagno models, we kind of started evaluating our model and these sort of autoregressive models, and found that the autoregressive models were working much better. And so we really invested in that. And we invested in a couple of things. One is the underlying image tokenization, the way that worked. And then the other was just scaling up these models to be much bigger. And so when we did that, we started finding we were getting really, really great quality out of that sort of approach.
That's an awesome progress. I imagine those milestones that you're hitting, you're getting more and more excited. So Mohammad, tell me more about your experience in this field and what got you to where you are now.
Yeah, maybe we can go way back then when I was an undergrad in Iran. A whole bunch of my friends were doing theoretical computer science. And I was also into that to some extent. So there's this real feeling of satisfaction when you solve a problem and you really solving it.
Right.
But then I started doubting if I want to continue with theory for the rest of my life. So I started looking into other fields, some of cognitive science and psychology, and finally got to learn about neural nets, started implementing some versions of backprop on ConvNets, on MNIST. Actually, it's a black and white handwritten digit data set. Oh. And so what really excited me at the time, and still excites me, is the fact that you don't have to handcraft these models. You don't have to tell them exactly how to overlay a dog image on top of a forest background, where the lighting is, etc. The model just does it by itself, and it learns through going over a large number of examples. So it's quite distinct from everything else that we do in programming, in the sense that as a programmer, you may not have a solution yourself, but you just need to figure out the right composition of input outputs and the right learning algorithm, and it's just the model does it for you. And so it can enable you in ways that you may not imagine. And so with the text-to-image models, it's really the moment that we all felt like, wow, this is going much better than expected. And the model is doing these amazing creations that...
I'm sure it's very liberating.
Yeah. That sometimes you're even surprised when you see the model interprets the text input in a completely different and creative way. So it's really exciting.
That is so exciting. And so when you come up with all those different options, or the model does, tell me a little bit about two things. One, the guardrails around what it can create, so that, you know, as these models get smarter, we still have control of them and dictate what they can make. But then also tell me some of your favorite images that it's made. And all of these around us were made by these two models. So I think that's so cool.
For sure. So in terms of risks and considerations, I can list it. One is privacy, the other is copyright, the other is representational bias, in the sense that the world around us has a lot of biases embedded, unfortunately, but we would like to try to reduce these biases when we learn these models. And we actually do have ways of, it's a research problem, but we do have ways of trying to mitigate some of these biases and make the imaginary world in the mind of these models a better place. And another consideration is content creators, how we make sure that they are part of the loop, and especially living artists, their content is not being used in ways that they aren't comfortable with.
Right.
I don't know, Jason, do you have any other?
No, I think you covered it really well. You know, just on my part, my mother is actually an oil painter.
Oh, wow.
And has been, you know, for the longest time. She's been following all this with tons of fascination. And my daughter is just starting her art degree right now.
Oh, wow.
And so I'm really excited for her actually to have these tools at her command and soon to be developed, so that she can actually build this as part of her whole toolkit as she develops as an artist.
That's incredible. And what are some of your favorite images that you've made, both of you?
Well, the wombat is the spirit animal of Parti.
Right here?
Yeah, well, that's a capybara right there.
Oh, okay. I don't know all of my animals that well.
But
I know that's a dog, for sure.
There you go. Yes. If we can do dogs and cats, great.
Okay.
I had a graduate student, Elias Ponver, when I was at UT Austin, who introduced me to wombats, and they're amazing animals. And so I just started generating wombats when we were first testing out Parti's capabilities. So my favorite image actually is one that I created of a wombat warrior standing in front of the Arc de Triomphe in France. And so with mist swirling around it and all that. And one of the things that was really exciting for me recently was to be able to redo that after we hooked up Imagen super resolution to Parti's text to image generation. So we first generated a 256 by 256 image with Parti, and then Imagen takes it from there to make a 1024 by 1024 image.
Wow.
And it just really popped. And so it's been really exciting to have that additional level of detail.
That's incredible. I mean, the detail going from one resolution to the next, let alone making the image in the first place, is blowing my mind, I think. Mohammad, what are some favorites of yours?
Yeah, so one of the exciting things about these models is that now we are connected with a whole bunch of designers and artists within Google, because Google has a lot of great people. And these people, I think, weren't going to talk to us because we didn't have anything to offer, but now these models excites them too. So Irina Blog, who is a designer who actually designed the Android logo,
cool.
The celebrated Android logo, designed by her. And so she has this toilet paper with cactus spikes.
Oh gosh.
It just makes you uncomfortable when you look at it. So that's one of my favorites. She has another one with potato skin with strawberry texture.
Oh. It's like these things that you can't really even imagine until you see them, I'm sure. And so what's the ultimate goal of all of this, Mohammad?
I guess the short answer is we don't know, but there is a transformation in the making, like I was saying earlier. And I think design, photography, fashion, advertising will change.
It really feels like
you're
bridging with all of those sectors that you just described, whether it's fashion, art, business, anything in between. You're bridging that quantitative through the model and the qualitative of one's experience.
Right. So it's a new tool that we'll have to figure out exactly how to make use of and how to add more control to it. So it's a very interdisciplinary field, and that's exciting. But I can really see all of these fields embracing technology and changing in the years to come. So it's just a question of who wants to step up and make it happen.
Yeah, and you and your teams have really been stepping up. And so what's the future, Jason, for text image models? Are folks going to be able to use these soon? I know that some models are available for some use. What's the pace?
Yeah, no, I think it's a frenetic pace. We even see this with the open source release of Stable Diffusion recently, and now there's a huge wave of open source activity around this. In Google, we're really working on careful, controlled release of these kinds of model capabilities. And I would say this is like in partnership with our responsible AI group, where they feel that the best way to address these kinds of concerns that Mohammad was talking about earlier is to have specific applications in mind. So that you really can think about, well, what's the training data that I need in order to train a model for this particular kind of application? What are the guardrails? What is the actual purpose of this, rather than just a generic put anything in and get stuff out? So I think that that's going to be a really big way forward to really realize some of the wonder of these models.
I noticed in the internal demo that I was able to use with your models, you weren't able to use anything that involved people yet. And so is that an example of what
I mean, it's just like taking care right now for these things, because we're still working on the underlying ideas and methods for mitigation on biases, especially around people. And so we're just proceeding with care on those kinds of things. But I think also just, more generally for me, there's a huge area of scientific interest in this, because for me, I really want to understand how language works. I come from a language background.
Yeah.
I started my PhD in linguistics and then finished in computer science.
Oh, really?
And so, for me, these models are this really rich connection between language and image. One of the fun things is like putting in an ambiguous prompt and seeing that the model will actually represent the ambiguities in different ways. Like a cat on a box, it might produce a cat sitting on a box, or it might produce a drawing of a cat on a box. These are all valid interpretations, and the model kind of comes up with these. There's even this thing that people like to do hybrids of animals, and so they'll put in like, I want to cross between a giraffe and a zebra. Right? And, Imagen's actually a bit better at this than Parti is, because it'll happily make like a giraffe with zebra stripes or vice versa. Parti went really literal on this, and it had a giraffe with a cross and then a zebra. So it literally put a cross between the two things. So, and that's a legitimate language ambiguity. And I think that these models present a huge opportunity for us scientifically. And it's one of the things, we have these amazing images that kind of come out, right? Mm-hmm. But one of the things that happens is they still have a lot of failure modes. And we've really looked at and highlighted a lot of the ways in which these, really wonderful models still fail in a lot of ways. Like they don't do counting very well. They don't do spatial relations very well. And so we have to continue to work on the underlying science of these. And I think that will also help us understand how language works better, which is kind of the thing I want to get at.
Yeah, the background you have in linguistics, applying it mathematically in some sort of patterns and learning models, it is so intricate. I can imagine that it takes so many different experts and disciplines. And when you think of all of these challenges, Mohammad, we talked about guardrails a bit. What will this look like to actually help people, whether it's through expression or something else?
Yes, there's something deep about visual expression. You look at a scene and you just get it. Mm-hmm. There's no language barrier. There's not a lot of thinking needed to just look at an image and understand it. So it feels closer to heart to have visual expression as opposed to even a textual description. And yeah, so going back to what Jason was saying, we have all these models, machine learning models. Maybe through these models, we can help debug them and visualize their thought process so that people who use them can see what's going on behind the scene in a visual form.
And I imagine there's a lot of uses for just people's brains being able to visualize something in a picture rather than just through words. I mean, people learn in all different types of ways. But I imagine the accessibility component is significant.
For sure, yeah. So people are already talking about using these models for language learning, for example, for education, etc. So
that's amazing.
Some of my kids are very visual learners, including my daughter who's starting to do artwork.
Yeah.
You could definitely see this being a wonderful way to explore language and things like that. So actually, my eldest daughter spoke Portuguese much more than she spoke English growing up.
Oh,
and she used to play around with a really bad chatbots that we had in the mid 2000s as part of like practicing English. And to be able to play with something like this would be so much more powerful. And then you connect that up to some of the language models that are being developed, where you have the ability to interact with language and images and so on. That becomes a really exciting possibility.
There's so much here, and I'm really appreciative that we got to chat about it. It's been so exciting to really explore what Imagen, what Parti can do, and what's really coming next. I imagine bringing them together will be really something special.
We're definitely working on that right now.
Mohammad, Jason, thank you so very much for this awesome conversation today.
Thanks
for having us.
Today we heard from Mohammad and Jason, two research scientists who helped make Imagen and Parti, Google's contributions to the text-to-image space. Stay tuned for more episodes about helpful technology coming soon.